This video is on inverse of functions. So first we're going to start off by talking about what is one-to-one. So one-to-one, a short definition, is the y values cannot repeat. It is very different than being a function where x values can't repeat. So we have two examples where we want to determine is or are these functions one-to-one. And if it is, we want to find the inverse. If it's not, then that's really it. So looking at example 1, we're looking at our different y values. We have 6, 5, 2, and 10. None of them repeat, so yes, it is one-to-one. So one-to-one. Which means now we find the inverse. So the inverse, we just switch the x and the y. We have 6, -1. We have 5, 0, 2, 3, and 10, 7. So that is the inverse of the given points. Looking at example 2, my y values are 4, 6, 5, 4. So I see that my 4 values repeat, which means this is not one-to-one. So we do not have to find the inverse if it's not one-to-one in this case. Moving on to example 3, it says graph the inverse of each function. So this time we're given a graph, and we're going to want to end up switching the x and y values and regraphing the inverse. So I'm going to go ahead and label these points. So I have -2, +1. I have 2, 4 right here. And this point I have 3, -1. So I'm going to go ahead and switch the x and y values, and I'm going to graph it. I'm going to use green on this. So this first point, -2, 1, that inverse would be 1, -2. So I'm going to plot that point. I go over 1, down 2, and I have a point there. My second point would be 4, 2. So I'm going to go over 4 and up 2, plot a point there. I'm going to go ahead and connect those 2 points. And last but not least, I have the point -1, +3. So I go over -1, I go up +3, I put a point right there. And that is the graphed inverse. Okay. Going on, now we're going to find the inverse of equations. So I have 4 different ones we're going to do. Let me switch colors. So here we go. 4 inverses, all we do is switch the x and the y. But if I look here, I don't have a y, I have an f of x. Well, we need to remember that f of x equals y. So step 1, we switch our x and our y. So I get x equals 5y + 2. And then all I have to do from here is solve for y. So to solve for y, I'm going to subtract 2 from both sides. I get x - 2 equals a 5y. And then I divide both sides by 5. So I get x - 2 divided by 5 equals, and this is my inverse because I've solved for y, so I'm going to switch it to function notation. So it's f to the -1 of x, like that. Another way this could be written is, went backwards. It could be written as 1/5 x minus 2/5 x, or not x, just 2/5. So it's important to know both ways to write it just in case you get one answer but the other is one of the answer choices. Looking at letter B, I have g of x equals x - 4 divided by 7. So I'm going to go ahead and switch that g of x to a y. Okay, and again, step 1, we switch our x and our y completely. And then we solve for y. So to solve for y, I'm changing numbers on us. Some of you are probably thinking, what is she doing? So let me fix that. There we go. So to get the 7 out of the denominator, I'm multiplying both sides by 7. I get 7x equals y - 4. To get the 4 to the other side, I add 4 to both sides. So I get 7x + 4. And then I switch it back to function notation to show that I have the inverse. So there's the inverse of g of x. Looking at letter C, I have h of x equals the square root of x plus 1 under the radical. That minus 5 is not under the radical, so this is something you really have to be careful with. So again, I'm going to switch the h of x to a y. I have the square root of x plus 1 and then minus 5. I switch my x and my y. And I get that, and I start solving. So I move over this 5 first. I get x plus 5 equals the square root of y plus 1. To undo the square root, I square both sides. I have x plus 5 squared equals, those cancel out. I'm left with y plus 1. I subtract 1 from both sides, and I get x plus 5 squared minus 1. That does not get to go under the radical, which that's my inverse, so I'm going to switch it back to function notation. With square roots, you have to be very careful about your domain restrictions. I'm not going to go too much into the video about it because that's not something I'm focusing on in this lesson. But just know there are some restrictions, and when we get into the radicals unit, you will get to see what those are. Our last example, D, again, I'm switching the a of x to y. It doesn't matter what letter it is, f of x, g of x, h of x, a of x. They all represent y. So I keep changing them to y. So again, step 1, we switch our x and our y. And then I solve for y. So I'm going to subtract 3 from both sides. I get x minus 3 equals, oh, and see me, I'm changing my exponents. These exponents should be a 3. Apologize for that. There we go. So I get y cubed. There we go. That looks better. To undo something that's cubed, we do what is called the cube root. So that's a radical with 3 in the index number spot. Okay, so I have the cube root of x minus 3, and it equals, those cancel out, so that would be y. So I'm going to go ahead and switch it back to function notation, and I get that. The negative 1 in the function notation is just denoting that it is the inverse. Let's see if I have any more. Nope, that's it for this video. The next video will be over inverses and compositions to see how they relate.